Hi guys, how are you today? Today's video we're gonna go over the homework problems, page 425, 11 through 14, 17 through 19, 23 through 28. This is for section 5.3, the day number 2. So we're talking about sum and difference identities as we started on Monday. For number 11. The question to start with says, write the expression as sine, cosine, or tan of an angle. And you guys see I circled an angle, which means one angle. So instead of having two angles, which are in this case the 42 and 17, you got to write it as a single angle. That's what the question meant. It's a little bit maybe challenging to choose which identity to use. That's why on each and every slide you see a lot of writing, but this is basically just I copied pasted the identities so we can have them in front of us as we're doing the problems. You can ignore the 10 for now because tomorrow this is our work to add the 10 identities, and you can ignore this one as well because this has to do with 10. Number 15. So we're going to focus on those four identities, 26, 7, 8, 9. So I compare. How did I know that it's identity 29? I compare. I see sine and cosine mixed together. So it's not the first or the second. So it's not 26 or 27. So it could be 28 or 29. I see a plus, and a plus means sine of x plus y. But the minus would be the sine of x minus y. So minus means this is a sine x minus y, which is identity 29, the last one. And by x and y, we just mean first angle, second angle, okay? So first angle is 42, second angle is 17. Difference of those two is 25. Number 12, we see plus and cosine, cosine, sine, sine. So cosine, cosine, sine, sine with a plus. As you guys notice with cosine, the difference leads to addition. As you guys see, difference leads to addition, and addition leads to difference with cosine. So if you guys see right here, we know number 12, it's gonna be the cosine of a difference because you can see an addition in the problem. So it will be 94 minus 18, which is 76. I'm trying to find something easy to point with on my iPad, but this keeps, whenever I use the pen, turns into blurry. On my computer, I have the pointer, but unfortunately, the video came blurry. Next time I'm gonna try to use my wireless mouse, see if I can connect it to my iPad. Sorry about that. Okay, number 13. So I see mixed sine, cosine, sine, cosine. So I know for sure a mixed means a sine. And with sine, it's nice because if it's plus, it's addition. So it's plus in the problem. So I know it's an addition of two angles, which are pi over 5 and pi over 2. Pi over 5, pi over 2. And then to add them, we need a common denominator. So it will be 2, multiply the first one by 2, and the second one by 5. So it will be 2 pi over 10 and 5 pi over 10, which leads to 7 pi over 10. And that's all. That's all what you need. You can't stop here because if you stop here, you don't have a sine of a single angle. Those are still 2. So you gotta make a common denominator. Number 14, it's a mixed, which means it's a sine. Minus, it means it's a subtraction. Using a common denominator, you get 4 pi over 21. So multiply the first by 7, the second by 3. 7 minus 3 is 4. Common denominator is 21, which is the multiplication of 3 and 7. Okay, so this is the first set. Then 17 through 19. Now, it's a little bit different because you don't have, both angles aren't numerical. So one angle is numerical, the other one is a variable. It doesn't matter. Still apply the same thing. We see it's not mixed. It's cosine, cosine, sine, sine, which means it's cosine. If it's a sum, it means it's going to turn into a difference. This is how cosine works. So it's pi over 7 minus pi over 7 minus x. Because right here, again, not both angles are numerical. And that's all. That's all what you need to do. Right, as a single cosine or sine of a single angle. The next one, it's very similar to the previous one, except that it's a subtraction. So with cosine, it's going to turn to a sum of two angles. The two angles are x and pi over 7. Number 19, sine, cosine, cosine, sine, which means it's a sine. When you see the mixed, it means it's a sine. And the sign goes with whatever you have. It's a subtraction. It's a subtraction here. So the two angles are the 3x and the x. So 3x minus x is 2x. And every single time I put which identity I have used. So you can compare it here and see it. This you're going to see on every single slide as we discussed. Okay, 23 through 28, and we can skip 24. So 23 to start with, prove the identity. So here it's a little bit different. I'm going to do the proof in a separate video.